Okay, so for this activity, so we will create a new project. So for 8086 microprocessor, so we will create the schematic that we will going to use in our activities. So let us create a new project. So click on new project. So let's name it DRILL1 or drill 1.0. So click next, next again, next. Then under the firmware, so create a firmware project. Then select on the 8086 microprocessor. Then for the compiler, so select on MASM32. So if this is not installed in your device or in your Proteus system, so click on compilers, then search for MASM32 and click on download. So click next again. So for this activity, we will be dealing with the schematic and firmware of the 8086 microprocessor. So click on finish. So here is the source code. So we will not be using this. So just delete all those. Then go to schematic capture. So here we have the 8086 microprocessor. Okay. So next, so let's add an octal D-type transparent latch. So let us place a component, or just click on component mode, click on P or place, then search for 74 HC7373. So here we have the octal D-type transparent latches with 3-state output. So click on OK. So place it here. Then another one. So let us place or look for an 8255A. Okay, so this is the programmable peripheral interface or PPI with 24 I/O lines. So click on this device. Then place it in our schematic. Now let us add a terminal bus. So we'll connect AD0 to 15. So D0 to D7 of the this latch. Also D0 to D7 of the 8255A. So click on. Then another one for the D latch, and another one for 8255. So let's start by connecting AD0 to 15. Also okay. So we'll connect D0 to D7. Now let us change the label or string. So let's type in 80.0.15. Also for this bus, so that is 80.0 to 15. And this one also 80.0.15. Now let us connect D0 to D7 to this bus. Also D0 to D7 of the PPI. Then let us change this label. Okay, so please wire label. So this is 80.0. This is 81. Two. This is 83. 84. 85. 86. 87. And also this one to 80.0 to 87. $86, $87. Okay, so you may refer to the schematic circuit I sent to you in our MS Teams. So next we will connect OE. So OE is a three-state output enable input. So this is an octave low. Then pin 11 is LE, or that is the latch enable input. So this is an octave high. So we're going to connect it to ALE. So OE is connected to, we will connect this to logic state 0, since this is an octave low. So go to devices, pick devices, so type logic state. Okay, so logic state, okay. So this is logic 0, logic 1. So let's connect OE. Then LE is connected to ALE of the microprocessor. Okay, so next, so we will connect Q2 to A0. Sorry, Q1. Q1 is connected to A0 of the TPI, Q2 to A1. Then we will connect the reset and CS for the chip select of the TPI to active low. Then connect the chip select. And also we will connect RD to RD of this PPI, RD and RD of PPI. Then the WR to read write. Okay, so I think we're all set. So double check with the schematic. So now we're ready for our interface. So let us try putting LEDs. So let us use port A using mode 0. So let us put some LEDs, a LED. Okay, so let us choose this animated bicolor LED. This is animated green. So let's try this one. Click on OK. So let's connect it to port A. Alright, rotate clockwise. So I will connect the positive terminal of the LED to PA0. Then I will connect ground. Then let's start coding. So for the code, so we will define a port control. Then we will enable mode 0 and set all port to output. So let's start. Let's start in data segments. Data segment. So let us define port A. Let us define all the port. So AQ 00H, port B. I'm sorry, port B. So equate the 202. Port C. So equate to 04. Then let us have a port control or port connection. So equate that to 06H. Then data ends. So these are data segment. Then for the code segment, so let us move our data to AX. Then AX to the data segment, DS, AX. Then let's start our code with origin 000H. Then let's start defining our port. So start with our port con. So let's use let's start the X port control. Okay, port control. So move AL 10000000 binary. So this enable the mode 0. Let's type that. So enables mode 0 of 886. Then out, let's use a port D or TX register. Then let us toggle this LED to turn on and off. So let us create a loop for that. Then let's type in move AL, let's say 000H, H 8-bit. Then move the X port A. So port A to output. So we will transfer 00 to our port A. Then to toggle, so let us use AL FF. So all the 8-bit of port A 0 to port A7 is on or high. So this is low, this is our high, or on, this is off, this is on. So do not forget to put 0 after the letter. So H, so move the X port A, then out the X AL. Then let us loop back to L1. So this is the end of our code. So code segment, code ends. Then let's type in N. So let us build our code, build project. So as you can see, compiled successfully. There's no error. Then let us go to our schematic capture. Then click on start or run. Okay, there's a simulation errors encountered. Okay, valid memory size. So let's go to our schematic. Double click on our 8086 microprocessor. So let us change the clock frequency to 1 MHz. And the internal memory size, so let's make it 0x 10,000. Okay, then let's run again. Okay, so actually there's a communication between the CPU and this 8255A, but I think we have error with the LED. So let us choose another type of LED. So let us choose this animated bicolor with self-flashing. Let us choose the green one. Okay. So let us put it here. Okay, so let us not remove first this one. So let's connect it to pin 1 of port A. Then connect it to ground. So run again. Okay, so this is flashing now, or toggling. So now let us remove this LED. Okay, so let us change this one. Connect it again. Okay, so now we have this circuit schematic. So there's no communication between our microprocessor and PPI, or programmable peripheral interface. So let's go back to our source code. So since we put here 00, port A, all zeros, and port A to all 1. So let's make this one AA. So AA is 0101 0101. Then let's make this one 55. So 55 is 1010 1010. So compile again. Okay, sample run. So let us add 7 more LEDs. So copy. Okay, 2, 3, 4, 5, 6, 7. Another one, 8. Then let's connect it to port A. Okay, so let's move this. Okay, so connect it to a common ground. Then run again. So this is our A, so 0101. Then for 55, so that is 1010 1010. So it cycles. So that ends our drill 1. So drill 1 covers the schematic, and this part is for testing our circuit if it is if the 8086 microprocessor is communicating with the 8255A with the use of DRILL1.